All right, I've started recording, so if you have anything you don't want to have everyone hear, you can leave it in the chat. Let's try some more of these fun problems. And just make some things up here. Let's try this problem. I don't like these distances. Yeah, that looks better. So here we go. We got a triangle and a rectangle. Shouldn't be too bad. So what we're going to do here is we're going to break it into two shapes. I'm just going to, oh no, that's the eraser. I'm just going to divide it here. I'll have shape 1 and shape 2. Now for this one, we got to know that the rectangle or the triangle, the center is right there. And for the rectangle, the shape center is in there somewhere. So if we write down our data, A1 is going to be 7 times 2, 14 inches squared. X1 is 1 inch. Y1 is 3.5 inches, half of 7. Area of 2, 1/2 base times height. So that is 4 times 3. 1/2, 4 times 3, 6 inches squared. Right? From here to here is 4. And this is 2 inches. That makes up the 6. Then we have to find out how far away we are. Remember, this distance here is base over 3. So x2 is going to be 2 plus base over 3. So that's 2 plus 4 over 3, 3.33 inches. Likewise, this from here to here is h over 3. So this is 1 inch. That makes this 2 inches. So y2 is from here to here, right? If this is 1 inch, that makes this 6 inches. Y2 is 6 inches. Do you see how I got that? And those come from your book, right? In the front cover of your book, you have the charts. You can see a triangle is h over 3 and b over 3. It's always towards the fat side of the triangle. And then you just do some manipulating. So now we can find x bar and y bar. X bar equals a, let's go right after it, 14 times 1 plus 6 times 3.33 over 14 plus 6. X bar equals 17. That can't be right. What did I do? 1.7. 1.7 inches. So somewhere over here is x bar. And then y bar is going to be 14 times 3.5 plus 6 times 6 over 14 plus 6. 4.25. So somewhere up here. Oh, wait, so that was 4, so it's got to be up here. So this is y bar. So we are in here somewhere for our center, our centroid. Any questions there? All right, now, when we talk about wide flanges, so there's some examples like that in the book of these wide flanges, and we just use the chart in the back of the book to help us understand where the center of mass of the system is located. So let's just say we have a system that looks like this. Oh my goodness, this is hard to draw. All right, we got these two channels. And we'll call this these are both C10 by 30s. Channels. And on top, we have a plate. And we'll say the plate is, I don't know how big it is. Let's go with 26 inches and 2 inches thick. We want to find this, and assuming that this is all straight up here, we want to find X bar and Y bar of this system. Now we have 3 shapes essentially. We have this shape, which is going to have a center here, this shape, which is going to have a center here, and this shape, which has a center in here somewhere. So you can see this problem is symmetrical about X bar. So X bar is going to be 13 inches. Now the C10 by 30, we got to get some distances here. So you open up to the back of your book to Appendix J. And we have W's in Appendix J. And where are the channels? Channels must be in the next appendix, some appendix. Where are the channels? Why aren't they there in Appendix J? Oh boy. Oh, they're in Appendix C. Sorry. So for Appendix C, we have shape 1. I want to do it in yellow. Shape 1, shape 2, and shape 3 up here. Now, when we look in Appendix C on page 491 in your book, it gives us the area of 1 and area of 2. Area of 1 equals area of 2. They're the same exact thing. A C10 by 30 has an area of 8.81 inches squared. It also, if you look up at the top, you can see the picture. It gives you the height of the channel. It gives you this height right here. We know how far up it's going, which is going to be key because we have to find the center of shape 3 when we add it all together. So you can see that's labeled as D. So if you look by 10 by 30, that's 10 inches. It also gives you the location of the center. It gives you this distance here, which is key. And that you can see where x-axis centroidal axis, your x-axis centroidal axis is. Well, it's going to be 1/2 of D. That's going to be 5 inches in this case. And since it's symmetrical, you don't have to worry about the other shape, the other situations. You just have to have those two distances. So we can see y1 equals y2, and they're both 5 inches. Area 3 equals 2 times 26, 56 inches squared. We don't need x1 because, or x3 because it's symmetrical. And y3 is going to be 11 inches, right? 10 inches plus the 1 inch to the center of that shape. So then when we go to do y bar equals 8.81 times 5 plus 8.81 times 5 plus 56 times 11 over 8.81 plus 8.81 plus 56. I got 9.56 for y bar. So it's pretty high up here, right? If we were going to mark it, it'd be up in here. But that bar is giant above it. It pulls it up. See how that works? See how to read that chart? I wouldn't worry about doing number 26 on your homework. That's kind of weird. Let's try 22 here in class together. Notice how when it says locate the x-axis centroidal axis, that's actually y bar. So at your seats, try number 22. It's on page 155. Oh, you don't have to do 18 on your homework either. Or 20. We're not doing center of gravity. So don't worry about 18 and 20. Here we have a channel and a W, so you're going to have to use Appendix J and Appendix C. So, our shape doesn't look much like that. We just call this top one number 1. I put a plus in there. And the bottom one number 2. Area 1, Y1. Area 2, Y2. So I go to the back of my book. Appendix C, we got a 12 by 25, 7.34. And Y1 is, well, we're not going to be able to figure that out. We need to know that, what distance? TW there. That's our distance from here to here is TW, right? This distance here, they call that TW. So TW equals 0.387. So we have to find this distance and add it to 1/2 of 0.387. So to do that, we will go to table J. And in table J, is that not in table J? What table am I in? B maybe? There it is, table A, not table J. I just said it came out wrong. Came out of my mouth wrong. So we got a 21 by 65. What? Where's the 21 by 65 at? Oh, 62. No wonder. (21 by 62). We have an area of 18.3. And we can see this here. Height is D. So D equals 21 inches. So that means Y2 equals 11 or 10.5 inches. And Y1 is going to be 21 plus 1/2 of 0.387. So that would be 21.194 inches. And then we just add them up for Y bar. 7.34 times 21.94 plus 18.3 times 10.5 over 7.34 plus 18.3. Y bar be equaling 13.78 inches. How'd we do on that one? Am I still on? Are people still here? Oh, I got some thumbs up. I forgot about the thumbs up. I'm used to my other class. I got to go to PowerPoint, so I don't ever even check this because I can't see the chat. So good. I see some thumbs up. That makes me happy. So I think that's all the new stuff I got for you. Just these ones with these beams and stuff.